We have two different types of exponentials. Does anybody remember the two types of exponentials that we have? Here's our basic formula, where that's a B as in boy. How'd it go?
Well, so I don't know yet, but it's struggle with like get it.
Whoa, okay, I'm excited for you. Okay, so we're gonna start here. Remember there's two different types of exponentials. Anybody remember those two types? One starts with a G and one starts with a D. Growth and decay, right? How do I know if something's growth? Growth means it's getting larger, right? So growth happens when our B value is greater than 1. And that makes sense because something greater than 1, when I times it, because that's what exponential means, it's timesing by that number multiple times, right? 2 times 2 is 4, times 2 again is 8, and so on, right? They get larger and larger as we go. But if I went ahead and had a decay is when our B value is less than 1 but greater than 0. Can anybody tell us why our B value always has to be greater than 0? Why can't it be -2? Can I square -2? -2 squared is 4. And I do -2 again, that's -8. Nothing wrong with that, except x. X I want to be any variable I want to plug in. And once again, what if x was a half and our B value was -2? So then that'd be -2 to the half. Can anybody tell me once again what that half represents? The square root. And can we have square roots of negative numbers? No, that makes them imaginary. And there's an infinite amount of values, because anytime I make it an even root, right, like a 4th, a 6th, 8th, and so on, okay, that would make it an imaginary solution, wouldn't it? Correct? Okay, we don't want to have those infinite spots. So B always has to be greater than 0. That's one of the keys. B has to be greater than 0. Alright? So we have those two different types. Let's go ahead and graph y equals 2 to the x. So if you don't know what this looks like, what numbers can we plug in for x? I can plug in any number I want. I'm going to start with my Fab 5. And when I plug this in, I like to start actually here below. Can anybody tell me what 2 squared is? 2 squared is 4. 2 to the first is 2. What's 2 to the 0? Do you remember what the 0 power is? 1. When we see our pattern, what's happening here? As I'm going backwards, for smaller values, it's dividing. As I'm going forward, I'm timesing by 2, right? And that makes sense because it's 2 to that power. So this would be a half. This would be a 4th. And that should make sense because that's 2 to the -2. And anytime I have a negative exponent, what do I get to do? Jump the line! Change the sign. Okay? So we're able to do that, hence 2 to the -1 as well. Jump the line, change the sign. Okay? So he looks like such. Okay? Can anybody tell me what will always be my y-intercept if I don't adjust our parent function? What will be our y-intercept every time? There'll always be 1. Because anything raised to the 0 power is what? 1, right? Does that make sense? Now I obviously can adjust that by timesing this by 2 or timesing it by 5 or a half or whatever I want to do by putting a number, let's say, here or something, then that adjusts that. That multiplies it, stretches it, and so forth, right? But if I just, my regular old parent function, okay, my regular old parent function will always go through the point 0, 1. If anything raised to the 0 power is always 1. Okay. Let's go ahead and do a decay graph. By the way, really quickly, what's our domain here? The domain. Ben's on it today. He's all in figures to get this girl asked out. You got it, food. Okay, negative infinity to infinity. What's the range? How low does this go? How low does it go? 0, right? Does it touch 0? Can I ever be 0? 2 to what power ever gets me 0? Nothing. So it's a parenthesis. It's approaching it, but it never gets there, right? And how high does it go? Infinity. All right, let's go ahead and do a decay. Notice, just because it's a fraction, does that make it decay? Is 4/3 a fraction? Yes, but notice that's a growth because 4/3 is greater than 1, right? Once again, I think sometimes people always think every fraction, sometimes, like in definitions, they're like, it's because it's a fraction. Just because it's a fraction doesn't necessarily make it less than 1. All right, 1/3 to the x. Once again, my Fab 5. Okay. So this right here, if I did -2, that's 1/3 to the -2. This is a good starting point just to remember something. How do I go ahead and do anything raised to the -2 power when it's a fraction? I can bring it to both. Or I'm going to flip the fraction, and then that switches the sign. So that's equivalent to just 3 squared, which is 9. 1/3 to the -1 is just the same thing as 3. 1, 1/3, 1/9. As you see, as my numbers are getting larger, what's happening? They're getting cut by 1/3, right? And that makes sense because I'm timesing by 1/3. And yeah. Right? Grab that. Notice what point did I go through again? I went through the y-intercept of 0, 1, because anything raised to the 0 power will always be 1. Okay. The next thing we're going to do is our transformation. A lot of times when I write it this way, people struggle seeing what that really means, so I'm going to write it a different way. Which still means the same item, just written differently. Right, you can grab it.
You like that?
No, they already cut. Okay. All right. So what we're going to do is, if you guys recall, we've done shifting before. Okay. This is the same thing, same shift. It's just a different parent function. That's the key thing to think about. Anytime you're doing graphing, you always just look for the parent function, and everything else from that is the same as any other shifting. Does that make sense? So what I like to do is I start with my parent, y equals 4 to the x. Do my Fab 5, okay, and I get 1/16, 1/4, 1/4, 16. Maybe I have a question on what I'm doing so far. That's just my parent function. Right, Maddie Smith? Where did that, you okay? If you have questions, that's where you guys need to ask me some questions. Yes. By the way, I forgot on the last example of 1/3 to the x. What was the domain of 1/3 to the x? Negative infinity to infinity, right? What's its range? Still 0 to infinity because it didn't cross, right? Okay. So on this one, what's the next step? Does anybody remember what you're next going to do? Are you going to go ahead and this right here shifts up? This goes ahead and multiplies y value because it's outside my parent function. That goes ahead and shifts this as well. I like to do everything with my x's first. So I'm going to do this shift. Does anybody remember what does that shift do? It shifts us to the right 2. Because what value makes that 0? 2. Does that make sense? Get it, hold? You good? Yeah. So is that my x's or my right or my y's? Because you said right 2. X's. So I take all my x values and I move them to the right 2. And they should give me these same values. If you don't believe me, what can we do? We can check them. Let's plug in 4. 4 minus 2. 2. 4 squared becomes 16. Just different x values to get the same y values, right? Basically, this is what our graph looks like, and we're just shifting it 2 to the right. And so the y values stay the same, the x values. Okay, order of operations next. Would you multiply or add 5? I would multiply, wouldn't you guys? Okay, that is with your y value. Anything on the outside, meaning here's our main function. He's on the outside of it, right? We're going to do to our y value. So I'm going to multiply all my y values by -1. And last but not least, the last step is that plus 5. It is also on the outside, so I'm going to raise everything up 5. So that is -79/16, which is just below, excuse me, +79. That's right below 5, so 80/16 is 5. This is 19/4. This is 4. This is 1. This is -11. Then all I have to do is plot those points. What normal number was I approaching but never got to? It was 0, right? But then we went from this graph to this graph because it flipped us. Does that make sense? Then what did we do? We shifted it up 5. What number will we never touch now? We won't ever touch 5. So I kind of do like a horizontal asymptote there, just for my knowledge that I know I'm not going to cross that. Okay? So 79/16 is very close, right there. So is this. Then 2. I'm at 4. 3, I'm at 1. 4, I'm at 11. So I have this. Don't cross that asymptote. That's cool. What's our domain? Still negative infinity to infinity. What's my range? How low does it go? What'd you say, Jacob? Sorry? Close. Always want to go least to greatest. Negative infinity to 5. So I want to just flip it. I always want to go the lowest I can to the highest, which you have the highest. Just piece by piece. When in doubt, you could just plot numbers, I guess, if you wanted to, right? That'll work out. Okay. All right. So, just make sure. Okay. The next thing is you guys have seen things that grow exponentially. You are a phoneaholic. Yeah. Okay. One thing, things that we see. Okay, let's say every day we go to a store. Okay? And it's a closeout store, meaning they're trying to get rid of their inventory, right? Let's say every day the price goes down 10%. Okay, and we're trying to find that happy medium of like, yeah, I want it to keep going down, but yeah, I don't want somebody else to buy it before me type of an idea, right? So you basically have something in your head of being $5 or something like that. Let's say something starts off at 20 bucks, and it's 10% off every day. How do I write an equation to help me out with that? What would be, the first day is $20. What's the second day? How much is it worth? What'd you say? Somebody said it. Thank you. 18. What'd you do? Can you tell me the process of what you did there, though? Oh, Chloe. Well, then I saw her mouth it over there, and then I'm like, that makes sense. You're far away. Chloe, 18. Thank you. Can you tell me how you got 18, Chloe? You guys are all mean to me. Mean old little circles. Love you all, though. You kind of did. What'd you do? Tell me your thought process. That's okay. So you basically times 10% by 20. That's what you did. Okay, that's perfect. That's exactly right. Okay? So what she did is she took the $20, she times it by 0.10, right? And she took that and she went 20 minus that amount, right? So another way to do it, what are those guys? 20, 1 minus 0.10. So if I'm decreasing a value, I'm going to subtract. What if something is increasing by 10% every day? I would add, right? So basically, here's kind of a quick formula. P parentheses 1 plus R. Right? Or minus, depending on if it's increasing or decreasing. Because the sales price, we're going down, so we're going to subtract it. Make sense? All right. What about day number 2? What would that be worth? I do the same thing. I go 18 times 10, which is $1.80. 10% that is. And I go 18 minus $1.80 is $16.20. Correct? Then what are we going to do? Again, times by 10%, which is taking off $1.62. That's $14.58. And so on and so on and so on. Okay, with me there? So, what would it be the price on the 9th day? Could I keep doing this? Who wants to keep doing this for 9 straight times? Not a lot of fun, huh? Am I not timesing this every time by 10% and going 1 minus that? This point. So really, I'm taking my principal, which was 20, that's what I started out as, and I went 1 minus my rate, which is 0.10, and I want to know after the 9th day, is that what I just said? 9th day? and I'm gonna raise that 9, because I'm gonna do this 0.10 or 0.90 9 times. Right? Does that make sense? Continuously doing the show? Alright, so if you guys will help me out, plug this into your calculator for me. Just so you know how to work your machine. Yeah. No calculator for you doing that. What do we get? So we got a second, Ben? I know. Anybody else got it? Yes? Yeah, not yet. You try it? Get it? What are you, Sander? You know how to do it on there? Let's check. It's important to know how to use the machine, right? So what I would do is go 0.90. Okay, carrot. Carrot it, get that, raise it to the 9. And enter it. Times that. Get it? Yours is slightly a little bit different. It'll be your 0.9. And you get it coming. 0.90. Good. Now raise it to the 9th power. Now yes. Okay, that one you want to see, you're not allowed to use on your test. All right, let's see the one that you did most likely to use. So, 1 minus 0.1, right? 0.9. In your case, let's all right, anybody else need help on their calculator? Okay. Where'd you drive? You drove to Seattle? How is it up there? No, they don't know how to do snow. In Vegas got snowing over there. You guys playing Vegas? Or? Yeah, it barely snowed, but it snowed like enough. Crazy. Yeah, it was cold though. Like Saturday wasn't cold. Saturday was a nice day. And then Sunday came in. I'm like, holy shit! It was really cold. The snow came. St. George having like 3 inches. All right. Okay. So another great place, guys. We're almost done with the lesson. It's a pretty easy day. The other place that we see exponentials is money a lot. Okay. Money is all about exponential growth. Okay. When you guys see your lovely pennies, we all know what we're talking about. Those pennies. You've ever seen the pennies? And you're every free. I only get pennies. I'm not pulling up the dollar bill today. Okay. But you get your bank statement. It's like your bank is now 2506. Yes, every 2 cents this 3 months. Right? You guys seen that before? If you're getting more than 2 pennies, proud of you. Okay. You got 4. One time, my most I got in 3 months was 80 cents. That's a lot. I know. I put my travel money for my my summer vacation. We just had to put it in a bank. That's 80 cents. That's like that's a lot of growth. Still, better enough. Okay. So here's the equation that you're going to use. A equals P. 1 plus r over n to the n t. Okay, will you need to know this? Yes, you will. Kind of get it, understand it. It's very similar to the last formula that we used, correct? The only difference is that n value. And the n represents the number of times it compounds in a year. Okay, most of us, when we have our lovely savings account, we have what they call quarterly. It happens 4 times a year. We get interest 4 times a year. Okay, does that make sense? And quarterly. You could have daily. What would that one be? You're getting interest every day. What would that be though? For n, what would that put there, you think? 365, right? What if it was monthly? What would I be putting in for n? 12. What if it was bi-monthly? Twice a month, 24. Weekly, 52. If you're not sure of what they are, kind of ask so I can help you out. Okay. All right, so let's say Granny, she takes over, unfortunately. I love Granny. But Granny had some money. And Granny's like, you know what, Jake, here's $5 grand. I like $5 grand. Do you like $5 grand? The Granny's, though, said, but the only stipulation is that you have to put this in savings until you go to college. I'm going to ask you a personal question, doesn't have to answer if you don't want. Are you going to go on a religious sabbatical? Yes, okay. For him, that means he's going to have how many years? Let's say Granny kicked over today. No offense to your Granny, hope she doesn't. My Granny's a bitch. So, if that's the case, okay, you roughly have 2.5 years, correct? Would you agree with that? He starts looking around, trying to put his $5,000 somewhere, because Granny says you can only spend it on college. Well, he's got 2.5 years till college. So he puts it in somewhere for $5,000. He looks around, he finds a pretty good interest rate of, let's say, 3% interest. That's pretty good if you're looking at a bank. But he finds a place that's doing it monthly. Okay, 3% compounding monthly. How much would he have by the time he gets back and ready to go to school? So let's put it in. 1 plus, what's our interest rate? 3%. So what are we going to put in? 0.03, right? Divided by 12, because that's how many times I will compound in a year, is monthly is 12, right? So what do I put in for this one? 12 times 2.5. Now, what does this represent up here? That's the number of times it's going to compound within your time limit. So if I'm doing 12 a year for 2.5 years, that's going to compound 30 times. Does that make sense? If it was just compounding yearly, once a year, hence why we'd have 2.5 times, right? Is everybody there with me on that? Understanding what I'm going for? Because it kind of helps you understand what the formula is doing. And what this per interest rate is, this is how much I get after a year. So they divide that by 12, because each time they do it, that's really how much percentage you're getting. Okay, but notice you're getting interest on interest more often, hence why you're going to make more money. The more times it compounds, the better you are off, because it means you're getting interest on interest more often. Does that make sense? Because we always want our money to grow with interest, right? Okay, so here's what I'm going to show you how I would plug it in my calculator. For those that have a calculator, I would follow along. I'm going to show you what I would do. I would not try to put this all in one shot. Granted, this is a graphing calculator. You would not be able to use this graphing calculator, but this is the process that I would do. So I would start with my interest rate, 0.03 divided by 12. And we got 0.0025. Make sure everybody's on the same page as we all do this. Good? 0.03 divided by 12. Then we're going to add 1 to that, aren't we? Because doesn't it have that plus 1 on the inside of the parentheses, right? So I'm going to add 1. Enter. Now we're going to raise that. For me, I have a caret button. So I'm going to raise that answer, and I'm going to put parentheses. It was 12 times 2.5. I'm going to close it. Enter. Now I'm at 1.077. So instead of normally, okay, never mind, that's the wrong thing. Don't worry about that. Then we're going to times that by, how much do we put in? Because Granny gave us how much? 5,000. So now, he has it, I don't know if you can see that, is 5388.91. 88. So he just got almost $400 extra just by putting it in a bank, right? Does that make sense? So $400 less he has to spend on books or other things. Thanks, Grandma. Point what? Because it was 2.5 years. 2.5 years until he gets back. In your case, what do you have? 6 months, so 0.5. Granny died today. No one ever Granny died. Huh? Oh, you're not going to go right into it? When's your birthday? And then you're going to wait a year? Yeah. Oh, because you're doing the schooling. I forgot about that. For little kids and speaking. Gotcha. Nice. But Granny, we like Granny. Thanks, Granny. So that 5,000 turned into basically $5,400. Right? Any questions on how I put that in? We run another one. Just a plug and chug situation. We can't solve anything right now until we get to logarithms. Right? Maybe, did I ever tell you guys I made 18 grand off of having a kid? Good time. You're like, how do you make money off of having a kid? I'll tell you. I didn't even sell it. Okay? So, you guys ever heard of Aflac? Right? So, there was somebody in the state of Utah that found they had a loophole about pregnancy. And so, you have to be like, if you're planning on having a child, this is a great thing. We were planning on having kids. So you start 10 months before you want to have. So you start a month before you're going to start trying to have a kid. Does that make sense? So we had a kid. So we put it on. We're paying $300 a month. Okay? And so when you have a kid, my wife had C-section, so she had to stay in the hospital. And that's what Aflac for, is for if your insurance doesn't cover certain things, they'll give you cash to do it. So my wife has C-section, so she has to stay in the hospital for like 4 days for the surgery and so forth. But anyway, so Aflac pays you a certain amount every day you stay in the hospital. And knowing previously, because my boy was my 3rd child, our other 2 children had to go into the NICU because we don't make very good lunch. Me and my wife. Our kids come out and they have not very good lunch. They've always had to go to the NICU. So we added that plan on just in case they went to the NICU. Anyway, $18,000 after we took him home. Utah, they don't allow Utah to do that. Made 18 grand. So if I put that into it, let's now think about that. Let's say I put that money aside, which I did not. I went on a vacation. Okay. So, 18 grand aside. Let's say I have that for my boy. Okay? We looked around. Let's say we just did like our normal quarterly compound. Okay? We're going to say, okay, yeah, we got some baby money, right? And, yeah, I feel a little weird getting baby money. So I'm going to at least give it to his college education. I don't know if you guys know, your interest rates when you go to like Zions Bank or just your regular state, you guys know it's not even 1%. They're not even giving you 1%. You guys notice that? They're most of the time giving you like 0.25%. Compounding quarterly is a normal thing. How often, how long until my boy gets to go to college? If it was born that day? 18 years, right, roughly, correct? So we put that in, okay, 18,000, parentheses, 1 plus, how would I write 25%? 0.25%. I'd go 0.0025, right? Divided by quarterly, that's normal for a normal bank, yes ma'am. Okay, because remember this is 0.25%, right? And if it was 80%, isn't that 0.80? I move my decimal twice.
Oh.
So I need to move my decimal twice, but I need to put zeros still in front of it. Does that answer your question? Great, still here? Nope. Okay, so if it was 30%, what is my decimal for 30%? 0.3, right? Because I move my decimal twice. But if I'm 0.25%, still got to move my decimal twice, but I have to put zeros. Let's do something a little bit to be easier for you. How about 1.25%? What would that be? Okay, 0.0125. But I just have 0.25, so instead of 1, what does it need to be? A 0. Really, it's that small. I don't know if you guys have really ever looked into it, but they're really, really small. Okay, compounding quarterly, 4. But then I have 4 times 8. Okay? So, once again, start with your division. Does it make sense why you're still your decimal or no? Just be honest. No, that's a no still.
I just don't get why the 2 is 2 zeros behind and not 1, because isn't that where the 2 goes?
So, it's 0.25. Right?
Makes sense?
Uh-huh.
Yeah.
So, just like if I have 30%, here's my decimal, so what do I need to do? 1, 2. So this isn't a 0.25? Isn't that equivalent? 1, 2. Every time. What does percent mean, by the way? Does anybody know what percent means?
How much is 1?
Per 100.
Yeah.
That's what percent means for every 100. So I have 0.25 divided by 100. Hence why 30% divided by 100 is 0.3. So if you have one in doubt, just take your decimal and divide it by 100. That's what it is. Is that a better way to look at it for you?
Mm-hmm.
Okay, what did we get when we plugged this in? Did we plug it in? Did you try? You should be trying. Let's go. Try, try, try. So start here. 0.0025 divided by 4. What's the phone, man? You have a phone? You don't have a phone? Most of the time in this generation we do. Okay. Did you get it? Man, we sucked at making money there, didn't we? Huh? I know. So that just shows you why you should look around. Are there some places, like, the reason why a bank account or a savings account on this one is so low is because they're not guaranteeing that your money will be in there at all times. Has anybody ever heard of a CD besides a radio CD? A certificate of deposit, it actually fines you if you take it out early. So you're guaranteeing them a certain amount of time. So there could be a CD that's worth 20 years, and that might be worth it to put in because they usually give you a higher interest rate. But the thing that it is you're just guaranteeing them that you won't touch that money for 20 years, and if you do, there's a fine and you pull it out. Make sense? So that's why you look around, figure it out. Okay, that's it. Let me make sure though. Bacteria growth, ooh, that's a good one. Huh? 2 on your own? Ready? Here you go, I'm gonna let you do it. I need to give you info. Let's say how much money you wanna have, 10 grand? She wants 10 grand. Okay, she put it in a CD, so this time she found it to be 3.5%. Would that be as a decimal? 0.035. Okay, let's say for 15 years. Let's do compounding daily. You're like, where do we find that? Okay, give it a shot. Compounding daily. 15 years, 10 grand. At 3.5%. Or 3.5. Ooh, bacteria growth. So hopefully you put it in by now. That should be your equation, right? I'm gonna go to my machine. 3.5. Let's do the 2.5. Just in this here. Divided by 365 plus 1, 3, 2, 365, 15, times by 10 pounds. Now we're talking. We got 16,904 and how many pennies? See, money makes money if you put it into a right facility. Okay. Here you go, 4-1. You're gonna do 5. Well, hold on. 5 through 11, odd. Nineteen through 35 odd. 47, 49, 51, 53, 55. There you go. That's